In this video, we're going to do a couple examples of solving a quadratic equation by using the quadratic formula. So we'll start with a quadratic equation, 2x squared minus x minus 6 equals 0. And before you begin, you do want to make sure all your terms are in descending order, the quadratic term first, then the linear term, then the constant, all on one side equaling 0. So for this problem it is. So we can now go and identify a of 2, b of -1, and c of -6. And then we're ready to use the tool called the quadratic formula. So just to remind us, that tool says that the x values would equal the opposite of b, whatever the b number, opposite sign, plus or minus a big square root with a b squared minus 4ac underneath it, and then a big fraction bar underneath everything, 2a. Alright, so we're going to use that formula, and we're going to start by very carefully inserting numbers for each one of the variables a, b, and c. So the opposite of b, again our b is -1, so the opposite of -1 is +1. Plus or minus, big square root. Now inserting our b, because it's negative, I'm going to wrap it in a parenthesis carefully, -1 squared, minus 4 is always in the formula, times 2 times -6, all divided by 2 times the a number, which is 2. So that's how much you do the first time through. Now the next time through, we're going to mostly work with the things that are under the radical. So we'll recopy the 1 plus or minus square root. And now our -1 squared, -1 times -1 is +1. And then we're going to look at this expression right here and think of this, not think of it, it is connected with multiplication. So first of all, think of the sign, one negative with the 4 that comes with the formula and another negative inside with the 6 would turn this to a plus, and then 4 times 2 is 8 times 6 is 48. So you do the multiplication left to right. I like to do the signs first, then the numbers. And then the denominator, the 2 times 2 is 4. Okay, now we're going to continue working under the radical. So for the next go through, we've got 1 plus or minus square root, and 1 plus 48 is 49, all over 4. Now in this case, let's move this up a bit so we have some room. So in this case, let's make that 4 show up a bit better. 49 is a perfect square. 49 under the square root is going to come out as a 7. So now what we have is 1 plus or minus 7 over 4. And because it came out completely, we want to separate this into two different expressions. So x would equal 1 plus 7 over 4, or 1 minus 7 over 4. And we can do each of these out separately. So 1 plus 7 gives us 8, and of course 8 divided by 4 is 2. So there's one of the solutions. And then 1 minus 7 is -6. Divided by 4 doesn't go evenly. We can reduce it to lowest terms. And just as always, we could write it in mixed number form or decimal form. But for now, we'll just leave that alone. So our solutions for this quadratic equation are 2 and -3/2. So once again, our quadratic equation yields 2 solutions. Now let's try another problem. And we'll see something a little different happen towards the end. So 2x squared plus 3x minus 3 equals 0. So once again, it's in the correct form, descending form. We have our squared term first, then our x, then our constant equals 0. So we're ready to assess the a value, which is 2, the b value, which is 3, and the c value, which is negative 3. And I'll just go ahead and write the formula again so we have it in front of us as we insert the numbers. Alright, so starting with the opposite of b. This time our b number is positive 3, so when we put it into the formula it will be negative 3, the opposite of the b number, plus or minus square root b squared. So now we have a 3 that's got to get squared, minus 4 from the formula times the a number 2 times the c number negative 3, all over 2 times the a number, which is 2. Okay, so just like before, we're going to start by attacking what's under the radical. So negative 3 plus or minus square root gets copied. The 3 squared, 3 times 3 is 9. And then we'll take a look at these three terms. So we have, again, a negative and a negative being multiplied to get us a positive. So this is going to turn to a plus. 4 times 2 is 8, times 3 is 24. All over 2 times 2 or 4. And we'll continue working under the radical, adding our 9 and 24. And we get negative 3 plus or minus square root of 33 over 4. Now what's different at this point is we look at our 33 and we say, well, that's not a perfect square. There's nothing nice that could be multiplied by itself to give us a result of 33. So what we do in this case is those are actually our solutions. And so what that means is that x equals negative 3 plus square root of 33 over 4. That's one solution. And the other solution is x equals negative 3 minus square root of 33 divided by 4. And if we were to graph this and wanted to take a look at what this would look like in terms of our x-intercepts, we would want to convert these expressions, these exact forms, to decimals. So if we input negative 3 plus square root of 33 divided by 4, we would get about 7/10 when rounded to one decimal place. And if we did the one with the minus, we get negative 2.2. So we could put this quadratic function, that is, if we came back to the original problem, and put 2x squared plus 3x minus 3 in y1, took a look at the graph, we would expect to see the graph cross the x-axis at negative 7 and negative 2.2. So our solutions can be written either in exact form, that is, these expressions with the radicals and the fractions, or approximate, that is, calculating it and rounding it so we can find it on a graph. So this gives a couple examples of using the quadratic formula to solve quadratic equations.